Hello, my name is Ahmed Masoud. I'm part of team number 5. This video is prepared as a part of our graduation project for the ME680 Advanced Design Engineering course. In this video, we are going to demonstrate our design challenge for designing the pressure safety valve transportation load isolation project. So the basic function of a pressure safety valve is to relieve excessive pressure from a pressure system by allowing that excessive value or excessive amount of media contained in that pressure system to come out of the system. And then the other function of the valve is to close again after opening and allowing that excessive pressure to come out. It should close again to maintain the pressure in the pressure system. So let's have a look about the internal structure of a conventional spring-loaded PSV. It contains a cast body that is connected to the pressure system through the inlet flange, and we have here the outlet flange from which the excessive media that is causing the increase in pressure in the pressure system to come out from. Other than the static valve body, we have some internal parts that are moving with relation to each other. One of the most important parts is the disc, which is kept closed against the nozzle, the inlet nozzle, keeping the system pressure always at a constant level. That disc is forced against the seat, which is a part of the inlet nozzle, by the action of a spring, a compressed spring, that is acting on the disc against the seat, maintaining it always in a closed position. So we can look at this equation that demonstrates the action of the valve while it is closed. So the force of the spring acting along the spindle on the seat is always kept more than the pressure force acting on the disc from the lower side by the action of the pressure in the pressure system. In the case that the pressure system increased more than the designed operation pressure, then the force acting on the disc would be, which is denoted here as the system force, would be larger than the spring, the action force resulted from the spring action, causing the disc to lift up, allowing the media inside the pressure system to come out from the outlet nozzle. After the excessive media gets out of the system, the pressure is regained back to the original operation design pressure, and at this case we return back to the main function where the spring would be able to exert a force on the disc and put it back into the closed position. So as we see here, the integration between the internal parts is very important. The arrangement of such parts is very important also for the PSV to function correctly, and the limited size inside the valve makes it very delicate and very sophisticated, and makes it very important to maintain that arrangement in the correct order in order to have the correct function. So what is our problem? Our problem that we are having with the PSVs is that it should be from time to time calibrated in order to assure that the force of the spring is equal to the force at which the pressure system would be allowed to be overcome and eventually letting the PSV to open. In other words, the PSV is required to open at a certain pressure system, which is very important, because if the system pressure increased or surpassed that value of the pressure system, the integrity of the whole system would be impaired. So it's very important, it's very crucial to have that PSV very accurately set in order to open at that certain value and not to exceed it. So in order to make that assurance, we take out the valve from the system and ship it or send it to a calibration test bench or a calibration workshop where we make sure of that setting by pressure testing the valve at the pressure where it should open, and see at how much pressure it will actually open, and evaluate the deviation from the setting pressure. And of course, that deviation has some acceptance criteria where the valve should not surpass. So, during the transportation or shipping of the valve back and forth from the calibration facility, a lot of problems might happen to the valve. For example, the valve is shipped in a container on a vehicle or on any means, and it is being transported on land. That land has irregular configuration or irregular surface, which eventually might induce some vibrations to the valve body. Those vibrations would, at certain values or at certain conditions, might impair the internal arrangement of the internal parts of the valve. So, and that problem has been experienced a lot with a lot of PSV users, and it has been identified as a major problem causing the deviation of those valves from their original setting point. So our target in our design project was to find a way to isolate those vibrations and all other sources of offsetting that arrangement from the valve, in order to maintain its calibration after it has been calibrated in the testing facility or the calibration facility, and before it is installed back into service. So, in a nutshell, our need is to maintain the PSV calibration by eliminating transportation loads.